Geological and climatic factors affecting the correlation between electrical resistivity and SPT value in sandy soils of Phuket, Thailand. Welcome to Journal Club. The latest academic research, explained in plain English. Today we're looking at this paper from MDPI's Journal of Geosciences. It's authored by Patiwangrak et al. From Asian Institute of Technology in Thailand, and is published open access under a CC BY license. Let's start by translating the title into more accessible language. When you read this title, you can understand it to mean in very simple terms that this paper explores how the geology and climate in Phuket, Thailand, affect the relationship between electrical resistivity and SPT value in sandy soils. Let's expand on that a little. This paper is exploring the relationship between the electrical resistivity and the SPT value in sandy soil in a specific place called Phuket, Thailand. This relationship can be affected by various geological and climatic factors. By understanding this relationship, we can better understand the properties of the soil and how it behaves under different conditions. Now we understand the title, which is a good start, but before we can break down the full paper, we'll need to catch up on some terminology, jargon, background information and context. Specifically, there are some key concepts you'll need to be familiar with. Let's define them now. Correlation. A relationship or connection between two variables. Electrical resistivity. The measure of a material's ability to resist the flow of an electric current. SPT value, a standard penetration test that measures the resistance of soil to penetration by a standard device. Sandy soils, soil that is predominantly made up of sand particles. Phuket, a city in Thailand with a humid tropical climate and distinct geological areas. Regression analysis, a statistical method used to determine the relationship between two variables. Geology, the study of the structure, composition, and physical properties of the Earth's surface. Climate, the weather conditions prevailing in an area over a long period of time. Humid tropical region, a climate region characterized by high temperatures and heavy rainfall throughout the year. Least squares method, a mathematical technique used to find the line of best fit for a set of data points. Now that we understand the title and key concepts, we're ready to dive in and break down this paper. In this presentation, we're going to attempt to answer 5 questions. 1. What were the researchers trying to figure out? Or more specifically, what was their hypothesis? 2. How did they conduct their experiment? That is, how did they test their hypothesis? 3. What were the results of the experiment? 4. What conclusions did the authors draw from those results? And lastly, 5. Why does this research matter? Why should you care? 1. What were the researchers trying to figure out? The researchers hypothesized that there is a correlation between electrical resistivity and the SPT value in sandy soils in Phuket, Thailand, and that this correlation is affected by geological and climatic factors. 2. How did they conduct their experiment? The researchers collected SPT value data and electrical resistivity data using boreholes and vest surveys in sandy soils of Phuket, Thailand. The SPT value data were collected from construction contractors and field surveys at various locations. The Wenner array was used to determine the sandy soil's electrical resistivity. The geological and climatic factors affecting the relationship between electrical resistivity and the SPT value were classified and validated. Regression analysis was performed to understand the behavior of the linear fitting coefficients and their sensitivity to geology and climate. The coefficient of determination was used to assess the empirical model. 3. What were the results? The researchers did not find any correlation between the SPT value, a measure of soil strength, and electrical resistivity in sandy soils in Phuket, Thailand. They found that geological and climatic factors played a significant role in the correlation between the two variables. They developed a negative and weak exponential relationship between the SPT N value and electrical resistivity when classified by geological category and climate classification, but highlighted that the relationship was inconsistent due to local geology and weather. The researchers recommended utilizing electrical resistivity surveys as a preliminary tool to evaluate problematic subsurface zones, and stated that further field test data from various regions and climates were necessary to establish an association between the SPT N value and electrical resistivity of sandy soils. 4. What conclusions did the authors draw from their results? The researchers found that geological and climatic factors do have an impact on the correlation between the SPT N value and electrical resistivity in sandy soils of Phuket, Thailand. They suggest a framework for non-destructively predicting geotechnical properties by using the correlated electrical resistivity as a replacement for physical parameters. This method is practical and can be used to determine the geotechnical properties of sandy soil in Phuket. However, a more accurate prediction model could be developed in the future through statistical analysis of a large database of SPT N values and associated electrical resistivity values. 5. Why does this research matter? This research paper is important because it investigates the correlation between electrical resistivity and the SPT N value in sandy soils of Phuket, Thailand, which is crucial for carrying out any building project correctly. By establishing a correlation between these two parameters, the time and expense of engineering field work for site investigation operations can be reduced. The paper examines the factors affecting the link between electrical resistivity and the SPT N value by using data classifications of geology and climate. The findings of this paper suggest that more field test data from diverse places must be acquired in order to establish the relationship between the SPT N value and electrical resistivity of sandy soils. We hope you've enjoyed this Journal Club presentation of geological and climatic factors affecting the correlation between electrical resistivity and SPT N value in sandy soils of Phuket, Thailand. If you'd like to read the full paper yourself, which we encourage you to do, you can find it at dra10.3390/geosciences13060185.